Now, if you tried filling in the rest of that table and had any issues with it, then I've just created this little video where I'm going to go through the rest of this table. We left off here. We had established that it was an acidic solution in that second row across, but we never did calculate the pOH in this solution. So how would I calculate the pOH? I would probably choose this equation. It is the pH plus the pOH added together gives me 14. So if I put in the value of pH, which was actually given to me in the problem, okay, then I could solve for the pOH. So 14 minus the 5.75 is going to give me the pOH. And that is a pOH of 8.25. Okay? Now, I don't like to tag off a pOH to decide whether it's acidic or basic. It's just an extra mental state for me. As the pH goes down, the pOH goes up for an acid. So I could do that, but I usually just look at the pH because I have that one drilled in my head. Low pH is acidic. All right, let's go through this bottom line here. In this case, we're given the OH minus concentration. Okay, so I have an OH minus concentration given to me of 4.5 times 10 to the minus 4. That's a pretty good concentration. It is greater than neutral, which is 10 to the minus 7. This is an OH minus concentration. So right now I know it is basic, because if it has more OH minus than pure water, that's the definition of being basic. But let's see if that pans out in all of our other ones. From the OH minus, it is pretty quick and easy to get the pOH. So let's go ahead and get the pOH. pOH is the negative log of this OH minus concentration of 4.5 times 10 to the minus 4. This gives me a pOH value equal to 3.35. Okay, so now I know the pOH. How about the H3O+? Let's back over to the left-hand side there. When I know the OH minus concentration, I can get the H3O+ concentration using Kw is the H3O+ times the OH minus. The job of this equation is to get me between these two. So I know 1.0 times 10 to the minus 14 divided by the OH minus concentration, which is 4.5, times 10 to the minus 4, that's going to give me the H3O+ concentration. When I divide those two numbers, I will get 2.2 times 10 to the minus 11. So here's another way for me to think about pH, the acidity. Okay, is it acidic or is it basic? This is a concentration less than that of pure water of H3O+. So if you have low concentration of H3O+, that is a basic solution. And lastly, we haven't done we've got the pOH. Let's get the pH. How do you want to get the pH? You've got two choices here. We can get the pH by taking the negative log of 2.2 times 10 to the minus 11. That would give me the pH. Or we can use this, and we can know that 14 minus the pOH is going to give me the pH. I don't care which way you go with that. You should be able to get the same answer, and that is nope, it's not. What am I looking for? pH. It is 10.65, sorry, 10.65. Whether you do it this way or you do it this way. Sig fig wise, this is raised to 11th power. That's giving you the front part. 2 places here, no, not places. 2 sig figs gives you 2 decimal places. So that right there is the pH. Is that a pH of a basic solution? Yes. Anything with a pH greater than 7 is going to be basic. So we have filled in the rest of this table, and you just let me know if you've got any additional questions.